Hey guys, Tim for MVP Machine. Got another update on the solar sand battery heater. If you missed the previous two videos, basically what you're looking at is a 4x4 inch aluminum tube with a 1/4 inch wall, and that is filled with silica sand, which is comprised of mostly quartz, which is an excellent conductor of heat. And these tubes intersect. There's basically a pocket with a hole that goes through to this chamber, and these are also filled with sand. They have these fins, which are machined to a very tight tolerance to intersect, and they basically go halfway through these vertical tubes, and they conduct, basically the sand conducts heat across the fins. And then in the back we have a heat powered fan, and we were able to get about 185, 190 degrees using just these inexpensive positive temperature coefficient, or PTC, heating elements. There's two of them in there, and they are sandwiched between these two aluminum fins. And not quite enough heat. These are 12 volt DC. So what I've decided to do is up the game a little bit. The problem we were having, not necessarily that not enough heat, these get to about 400 degrees, but what actually makes it out to the outside of the heater, and I'm talking in Fahrenheit, what makes it out to the outside of the heater was approximately 185, 190 degrees, and up here in the fins we're getting about 150 degrees, which for a small space heater is not too bad. And the heat powered fan, once it gets up to temperature, blows a gentle breeze through here, and it would work adequately for a well insulated small room, let's say 8 feet by 14 feet or so. Would probably work very well. But the problem is it takes a long time to get up to temperature, and well, these only consume, between the two of them that are installed in it now, they only consume 52 watts. You're running that full 52 watts the entire time. Otherwise you're not going to get the heat. So what I've decided to do, go a little different route and try it and see how it works, is use this industrial, it's an immersion heater, but it's not necessarily a water tank heater. 12 inches long. It'll wind up, it's 110 volt, it'll wind up going through the middle of this side plate, and this gets to about 1400 degrees Fahrenheit at its full temperature, but it's very quick. I tested it out pretty much like everybody tests it. You find the oldest pot you have in the kitchen, fill it with sand, and put the element in the sand, and within less than 2 minutes the element temperature was approximately 680 degrees, and the sand around it was about 420 degrees. So the idea behind this new element is that instead of using the full power of the element, I'll have it regulated with a thermostat that will control it, and it'll just be short bursts. Once the sand gets up to temperature, we will cut off the element and wait until it drops about 40 or 50 degrees, and then it'll turn it back on to heat the sand back up. So that's kind of the plan. I still haven't made the improvements to the heat powered fan on the back. I needed some more cooling fins on that, and I'm going to try and accomplish both of those things in this video. Okay, I've removed the top plate. As you can see, there's the sand in there. I machined these fins to a tight tolerance because basically when this is done and I'm happy with the way it works, there is no way really to get in between these to weld them. So the only welds on here will be at the bottom of these vertical tubes, and that will hold the whole assembly together. But I wanted to make sure that everything works as I planned, or as I want it to, before I commit to welding that because there's no disassembly after that. So what I have to do is basically drill and tap a hole on this side for the new heating element, and then I have to plug the hole for the wire that goes to the current PTC heating elements and remove those heating elements, and then I'll have 4 holes for the heating elements that are in there that will have to be plugged so I don't leak sand out. So since this is really not attached, it's just fit together right now, and there's a lot of sand, I've got to get the sand out. That's going to make a mess, so I've cleaned up the table and I'm just going to pull the top off. The sand is going to go all over the table, and so I can reclaim it. I don't want to contaminate it. Before I pull these off, I've got these vertical bars that go down to the bottom of this cavity, and they pick up the heat from the sand and basically provide heat to the middle of these horizontal fins. So I have those relatively snug fit in here. I'm going to pull those out first. And then I'm just going to let this silica sand go on the table and then reclaim it. Off of the table. So here we have the pockets that go where the tube rests on, and the holes that go through. So I'm going to empty this out and drill and tap that hole and plug up these remaining bolt and screw holes and the wire hole in the back. Put the new element in and we'll try it out. Now the silica sand is kiln dried. It's a little bit difficult to find, but it can usually be found at a building supply. Used to be very common. It was used in media blasting, but they kind of outlawed it for that purpose because it's very abrasive, obviously, but when it breaks down, it can become airborne and very bad for your lungs. But there's still building supply companies that have it, and that's what you want to use. This is far superior to if you're just trying to use regular sand. It doesn't have the conductivity, and it also has a lot of moisture in it, and this is kiln dried. It's screened. It's a really nice material. So we're going to make those modifications and we'll try it out. Okay, I have the heating element installed in one of the end plates. A few facts about that: it is available on Amazon. It's $29.99. This body, it's called a cartridge heater, and this body is 5/8 in diameter, and it comes with a 1/2-inch NPT thread to install it, and I tapped this plate and then I installed a backing nut on it to give it a little extra strength because it's only probably a few threads. And then comes with approximately 18-inch wire leads, 110 volt, and it is supposedly for industrial processes for heating solids and used in the plastic and rubber industry according to the listing. So I've also basically just plugged these with a nut and a bolt. These were the mounting holes for the previous heating elements, and then our hole in the back for the wire is plugged. So I'm going to clean everything up a little bit better because that sand can cause some gaps, and I'll reassemble it, refill it with sand, and we will test it out. Okay, I've got the base back together, and now I have to fill it up with sand from these holes. It'll be like a cup at a time, and just make sure it surrounds the heating element, which you can see in there. And once I get that filled up, then I will put the top piece back on and fire it up. Okay, I've got it back together. I have set up a couple of thermometers. They're basically contact thermometers. These are cooking thermometers for pots, but I've got one clamped to the middle fin. I've got one going down to the bottom through the sand. And the reason I don't use infrared thermometer is on aluminum they're basically useless. I can test the top of the sand once it heats up and see what we get, but it basically reflects off of the aluminum and gives you just basically room temperature or slightly above. So I've got the clock set right here. This one has two thermometers on it, but indoor and outdoor temperature, I don't expect those to be of any use to us because we're not going to heat this whole shop. But I've got the heater sitting on some Teflon blocks that I have because heating element can get 1400 degrees and aluminum melts at 1200 degrees, and I don't tend to leave it plugged in very long. I'm going to cycle it and see how it operates. But the reason for the clock is we'll see how quickly it heats up. And basically we're just hooked up to 110 volt. As soon as I plug that in, we'll start it off. So let's see what happens. And here it goes. And I'll fast forward through this till we get some meaningful heat out of it, but I've got to leave the camera going right now and see what happens. $16 minutes in, and this one's going to take a lot longer than the sand, but let's see where we're at. Down at the lower chamber. Looks like we're approaching 200 degrees. And I have this angled so it's not, you know, right up against the heating element. Let's see. That's just starting to make it to the outside, just starting to get warm. Okay, it's 4:13, and let's see where we're at. Up here, sand temperature is 300 degrees. Down here we've just started to climb on the fins, and pretty soon the heat-powered fan should kick on. Sometimes a little help makes these guys go. It's not quite ready yet. It's almost too hot to touch the bottom, but this isn't completely heated up. Okay, we're about a half hour in, and lower chamber temperature is approaching 350 degrees Fahrenheit. I've got the target set to 400. And how are we doing down here? Fins, they're gonna lag behind quite a bit, but it's picking up a little bit. And let's see if we can give the fan a little help. Fan does not want to start for some reason. think we might be getting too much heat to the top half of this, radiating off of it. Obviously, I need to add more cooling fins to this, and I may isolate it somehow from the heater, but we'll see what happens. We're going to let it go. It's an experiment, and that's why you do experiments. Okay, we're about at 38 minutes and we've hit the target temperature, or surpassed it a little bit, up here. And down here still a slow climb to get it up to the fins, but eventually it'll get there. I'm gonna pause this video because I'm gonna run out of space on my camera, but I'll pick it back up and you can watch the time. I'm not gonna change anything. We'll just see how long it takes. Okay, you can see where we're at on the clock, and it's getting quite hot. Still hasn't translated to the fins, but they're getting hot from from bottom to top. Fan hasn't started, and I'm sure it's because the top is getting too much heat. I've got my chilled block of aluminum. Let's see if that helps us out, but I kind of doubt it. That needs some serious redesign with the higher temperatures. But we are running at over 450 degrees in the lower chamber, and you cannot touch it. Down here it's dangerous. It'd burn you to touch it right now, so see if a little help. Fan still does not want to go. The fins are starting to climb. At a certain point, I'm going to disconnect power to this and see how long. Obviously the sand is going to continue to get hot from bottom to top. So we've been running approximately 44 minutes, I believe, and the whole idea behind this with the new heating element, which is, I put it on the opposite side just for convenience, but whole idea behind it is the sand will maintain the heat for a long period of time, and then it will just require short bursts of power once I have it thermostatically controlled to maintain the temperature, and that's hopefully where the efficiency will come in. So I will pause this again, and in a few minutes I'm gonna disconnect it, but we'll see if the heat continues to climb on these fins. And it looks like I need some major redesign work on the heat powered fan because it's not operating. So okay, we're 1 hour in. Up top here we're maxed out at 550 degrees down in, that goes down through this lower chamber, and here we're just crossing 150 degrees on that middle fin. It's much hotter in the lower fins, and that's going to continue to climb. We're 68 degrees in here, and it's not going to affect that at all in here. There's 22-foot high ceilings here, but all the heat that it's making right now is going up to the ceiling. I believe in video number 2, without me noticing, that the thermoelectric generator, which sits right here, I believe I cooked that. I knew I needed more cooling fins in here to make it operate more efficiently, and it's just unwilling to start right now, and this is ridiculously hot. up here, so we're getting way too much heat being transferred to this. I have a wood stove fan. If you've watched my other video where I made the propane tank wood patio heater, I show you the wood stove fan on top of that, and it actually has a device that when it gets too hot, it's like a little spring that will lift it off of the top of the wood stove, just an eighth of an inch or so, a heat actuated like a Bendix, and I believe that is cooked because it's not producing any power and didn't even start the fan. So that needs a major redesign, which I kind of knew going into it. I was hoping it would start and do something today, but I'm gonna let this run. I'm actually probably going to unplug it because I don't want the bottom to get too hot. Right now we're maxed out up here, and as I said before, the heating element is capable of 1400 degrees, which would melt the aluminum, and I don't want to do that. I am unable to get an accurate reading off of that right now just because of the lack of the proper thermometer, but I'm going to cycle it, and I believe the fin temperature will continue to climb because heat rises, and so I'll cycle it in 10-minute cycles, and we'll see what happens. So right now, unplug it, and 10 minutes later it'll get plugged back in, and this temperature should continue to climb. Okay, it's been off or unplugged for approximately 10 minutes, and we're approaching about 180 degrees on the fin, the middle fin, and up here we're still pegged probably about 600 degrees, if not more, down in the bottom chamber. And I'm gonna plug it back in for 10 minutes just because I don't want to lose heat. I want it to keep climbing, and we'll see where we go from there. Miraculously, the heat-powered fan just decided to work. I don't know why. It just came on, which kind of baffles me. And it's going at a decent clip. So we're a little over an hour and 10 minutes in, and it decided to work. It's spinning a lot faster than you can see it. You can go back to the side because you get the wagon wheel effect with spinning items. It's probably spinning at about 600-700 RPMs, but the hertz rate of the video makes it look slower, and sometimes from different angles you can see the actual speed. And actually it's on the screen of the camera, it's spinning the opposite way from what it's actually spinning. Called the wagon wheel effect. I explain it in my wood stove, propane tank wood stove heater video. Now it seems to be going about 1,000 RPMs. You guys can't see it though. Alright, I'm gonna pause it and come back at the 10-minute on mark for this cycle. Okay, this would be about the time where I would cycle it off at the 10-minute cycle. But what's happened down here on the fins, obviously because the fan is going, and it's really bothering me that I can't show you the actual speed of this fan or direction, because on screen it looks like it's going this way, but in reality it's going this way much faster, and does not seem to be any way or angle that'll show you the actual speed or direction of that fan. But I would estimate about 1,200 RPMs right now, and it's putting out some really decent heat coming out the front. I'm impressed. We're still maxed out up here. 150 degrees seems to be a good temperature coming off of these fins, so I'm going to cycle it off for 10 minutes, and we'll come back to it and see where we're at in 10 minutes. Okay guys, we've been off for another 10 minutes, and I just thought about something for the fan speed. I found an old phone I had, and I powered it up, and I'll show you. Let's see if you can. Well, on the screen of this phone, the old phone, it actually shows it spinning a lot differently. I'm going to try and record video on this old phone, and I'll put it in. I'm going to plug this back in and go for another 10-minute cycle time. Okay, another 10-minute cycle of on. I might leave it on for a while. This is probably going to be the last update unless anything miraculous happens, but it seems to be holding its temperature at 150 degrees on the fins, and I am guessing, well, actually no need to guess, we're at about 550, 560 at the bottom, and that's with 10 minutes on, 10 minutes off cycles after the initial hour or so of warm up. The fan is working. I'm very happy about that. I intended to do some modifications, but as it's working right now, and I know you can't see the fan speed correctly or direction, but as it's working right now, we get a gentle breeze out about 2.5 feet from the unit, and pretty much exactly about what I expected I would want out of a unit like this. So I'm going to let it run, probably explore a little bit longer run time, and then seems like the 10-minute cycles maintain the temperature perfectly though, staying right at the right 150 degrees, which is nice, and we're maintaining the temperature also down below. So the next video I do, I will be installing a controller for this, either a thermostat or a digital controller, and it will have sensor inputs that will control it to make it a little safer, because if I left this plugged in, it would be a meltdown. But I am going to leave it plugged in for a little while longer here, and I may be back in a minute. I'll keep the video paused, and if anything miraculous happens, I'll come back. Okay guys, I'm back with one final update. It's been running approximately 2 hours, and cycled on and off for the last hour with every 10-minute increment, and I did leave it running for 20 minutes, which the temperature will probably climb, but it takes a long time to translate from the heat being produced down there to the fins, which the thermometer is clamped to the middle fin. And up here, it just pegged it. It's ridiculous. So I'm going to unplug it. I'm going to see how long it takes and keeps producing heat and keeps the fan spinning. Could not be happier that the fan is working, and even though you guys can't see the true rotation and RPMs, it's putting out meaningful heat. And right now plugged into 110, but definitely could run on solar and require a little bit more of a system than I originally envisioned. Would require an inverter and also a battery, but definitely doable. And the idea behind this, I made a 1 foot long unit, but it's definitely scalable. That aluminum tubing, you can purchase that in any length and add the amount of heating elements that you need. But what's nice about the sand, it takes a while, but it does transmit the heat and it holds on to it for a long time. So as I power this down here, likely for several hours, this will continue to produce usable heat where it's not costing anything, either solar out of your battery or if you had it plugged into 110 volt outlet. So I'm fairly optimistic about it, and next video we'll have some sort of thermostat or controller installed, and it'll be operating like a normal heater. I had intended to add cooling fins to the fan assembly, but it took a little longer than I thought to start, but it appears to be working perfectly, so I'm not going to do anything to it. It's about the right RPMs and producing a good amount of heat. So thank you for watching. Please feel free to comment, and if you're not subscribed, subscribe so you can see updates on this, and we'll see you in the next video. Okay guys, one last update. It's been off for well over an hour. We're getting ready to go home, but we're hovering just under 150 degrees on the fins, and fan is still going. We're at roughly 460 at the bottom in the sand, which is in the main chamber. And I did figure out, I reached back here and touched the top of the cooling part of the fan assembly, and it turned off just to feel, I touched it to feel what the heat was like, and it shut off immediately. So all I did was one turn, light turn to snug up these two screws on the bottom, and it came right back on. So that was probably likely the original problem with the fan not spinning properly or starting. So as soon as the aluminum expanded, it got up to temperature, and it made the proper connection from the heat differential on the Peltier junction. So that is it. We'll see you guys in the next video.